All right, I'd like to welcome everyone to EOF Implementers Call number 68, Wednesday, March 5th, 2025. The agenda we have set up, testing update, client and compiler updates. Then we're going to go through the Osaka testnet plan in priority order for our meeting notes. First, make sure we have all the changes ready for DevNet 1. Then look at the DevNet 2 changes. Willie Morris is on to talk about pay opcode, so we can get his understanding of it in case we need to explain it to all core devs. If you have any other things you want added to the agenda, please bring it up in the chat, and we'll get to it after we get done with. We'll look at it after we do client updates. So first up is testing updates. Mario, do you have anything for testing for us?
Not really. I've been focusing on everything that came from Poleski and now Sepolia. So yeah, no that many updates on EOF.
Yeah, that's totally understandable. It's been a circus this week. Cool. So on testing, we're probably going to need to start. This is probably more of a DevNet 1 thing. When we start implementing these things, we're probably going to need to update some of the tests to reflect some of the structure changes we're doing. So if everyone could take their current implementations and put like a EOF DevNet 0 tag on it with Git, that would help us be able to recreate what we have now. So when things go forward, we'll be able to get it. Client updates. Let's start with Reth.
No changes. We are still DevNet 0. Yeah. Maybe I'll ask later. That's it. No changes.
Okay. Besu, Lewis.
Also, no changes here. Still at DevNet 0, as far as I know.
Okay. I'm not seeing another mind on the call, and I'm not seeing a Geth. Is that correct? Okay. EVM1. Here, speak loud.
Can you hear me now?
That's great. Go ahead.
Need to mute.
I'll mute. Go ahead.
So we've got the TX create bringing it back in progress, and also the EOF create hashing change, and we've also prototyped one of the quality of life improvements, which was the EOF create order of stack arguments. I think that's it.
Okay. Your mic's off. Cool. We're all in the same room, so it's kind of a different experience. And I think that's all the clients that are on. We don't have anyone from Aragon or Ethereum JS on the call, it looks like. How about compilers? I'm not seeing who I was expecting for Solidity or for Viper. Do we have any Solidity updates? Our Solidity guys outside.
No, Radek.
Yeah, Radek was here, but to my understanding, there was no really changes to Solidity compiler. The stuff that has been done before last week are in the main branch, and not so much so far.
Okay. All right. So any other team updates or compiler updates before we go on to the main discussion for the meeting?
Actually, there's one testing update that I don't know we were surfaced on the EOF Implementers Call last time. We have a new release, 2.2.0, right, of the EOF pre-release test. So if you're you would like to download this and report back with status whether you're passing the new release of the tests.
And this is with EOF DevNet 0?
This is EOF DevNet 0, yes.
Okay.
There's new tests on top. And Spectra compatibility.
Okay. And I expect this will probably be the last release for 0, and the next one will be for 1, because we're going to be in the middle of working it over the next couple of weeks. Okay, we'll see. Second call for EOF client or compiler or testing updates.
Maybe more like a question for DevNet 1. When should we plan those changes to hit the next testnet, DevNet?
That's exactly. Let's start off with that discussion. That's probably where I was going to start it.
Yep.
So,
Cool.
as far as timing for EOF goes, I've prioritized our DevNet plan in such a way that we can have DevNet 1 done, and after that we can take whatever the most current DevNet is when PureDAS ships. PureDAS is important enough that they've made it clear that anything that's not ready when PureDAS is ready will be left behind. It is not just a headliner, it is the sole and singular driver of this next release. So if we're not ready to ship EOF when PureDAS is ready, we will go to Glamsterdam, which has an indeterminate ship date, which is not a good place to be. So EOF DevNet 1 changes, I've included everything that's a breaking change. And it would be great if we could get that finished in the next 4 to 6 weeks and tested. So I need to get Besu and EVM1 ready to do tests here in a couple of weeks so we can get everyone to get weeks and we can start fuzzing and get something ready for an EOF1 DevNet, ideally when Pectra ships would be the ideal time. So if we could get our code and we could start working on these changes, and what I want to do on the call today is finalize what needs to change for the clients. There's 3 outstanding items about the Omnibus PR, but I've posted a PR that's going to change all the EIPs. I have concerns. I'm going to have to split it up 6 ways to get it past the EIP editors. If they're sticklers about the one IP EIP, I'd like it to be a coordinated change, but we may not get that. So,
that sounds great. So something like 4 to 6 weeks for DevNet 1, and that's mostly the major changes that we want for EOF are basically there. Cool.
Right. And then from that point, I think we would probably do like a 3 or 4 week cycle for DevNet 2. We try to figure out what we can scope in, and then DevNet 3, DevNet 4, based on the priorities and based on the appetite we get out of ACD for adding new features. As I mentioned before the call started, we need to be prepared for the risk that ACD may say that all we get is EOF DevNet 1, because there's been some scoping discussions and adding in some more riders into EOF might cause political problems. Try and get them in, but we may need to sacrifice them for political purposes to make sure that other things don't get it as well. So that's the risk we run. But I think ideally what I would want in DevNet 2 is if we decide to do pay, we should get it in this release, get the metadata section, get that nailed down, and then the ext code address and the ext code types, which were necessary for the ERC 721 contracts. But the 2 open questions we have.
Code type seems important. I would even want to push it inside DevNet 1. It's not that big of the change. It's just one opcode. Yes, it's not crucial. It can be added later. But I feel that it can be bundled inside DevNet 1. That's just my opinion. I wouldn't mind if it is in DevNet 2. But I feel that, important to add it in first iteration.
Okay, and public code address too, I think is another important one. Let's try and let's loop back on this in 2 weeks and see how much progress we get between this and the next call. Because I think the real deadline for EOF DevNet 1 is we want to be able to launch it about the time Pectra goes up. And that's the signal that all core devs is going to need that we're ready to go. So we can add on if we get done early, or if Pectra slips out even more than we would like it to, which is a risk, small risk, but not zero. Okay, so let's do the second one first. Let's talk about commit hashes. This one should be quicker. Let me find the page of the omnibus. New address. What is the final form of the hash? Is it FF sender salt or just sender salt? And is it 32 or 20 bytes? I am okay with all of those. Let's just pick one.
Can you pull up random.org?
Huh?
Can you pull up random.org?
So what I have printed in the PR right now is FF, which matches create to sender salt. It is the same as create to. We just get rid of the init container part. No, this is literally is create to. What's the EIP number for create to? 2015. Okay.
Well, it also has the init container. I mean, init code hash, right? It's create two, so that's
If I can type the number in, right? Yeah, it has the init code, so it would be
less, like 32 bytes less.
yeah. So it would be we get rid of the init cache. So it's just like create, and the concern about collisions are not a problem because the length of the hash is significant. So they can't use it to create collisions any more than any other hash could be used to create collisions.
Yeah. I think someone Piotr commented that keeping the FF prefix is like the least change
Mm-hmm.
some way.
Okay.
I think this at least the least number of arguments we have to provide to this to justify the decision. Right? I mean, if it, I don't know. I mean, I was preparing like removing prefix at the beginning. It's the easiest to implement, but you also need to put this implementation in some different place. But maybe you'll have to do it anyway. So
Why was it put in create to in the first place, the FF?
because it kind of blindly guarantees no collision with RLP encoding. But I think it's strictly not needed because the RLP encoding of the address hash for create instruction will have always different size as well. So it will never collide. But if you put like FF, it's really unfeasible to have RLP encoding that starts with the same byte. So it will differ on the first byte. But I think Ketrag guarantees that even if the length, I mean, the input is the same, but the length is different, it will not collide on the hash. So it was a bit too much to my taste, but it was kind of old times, so nobody fully analyzed that. So yeah, but that was the motivation, right? To have no collision with the other address scheme.
So we'll retain it for consistency. All right.
I don't know.
Avoid this conversation.
All right. That's, like I said, I'm okay with all of them. Let's just pick one. The next one is kind of a different question, and I think it has more of an open-ended decision. Creator contract for EIP 7873, how feature rich should it be? It specifically should it include a flag to include the caller in the final salt for non-front runnable deploys? How would we put that flag in? So that is, did I get that PR up here?
So there was announced that the creator contract is more feature rich. So it not only allows to bootstrap new contracts, but also to serve, as I understand, as a replacement of the null to field on a transaction, each transaction in legacy. And then, like on the other hand, we would like the creating contract to be as small as possible. So it's easier to audit. It might eventually just not be used anymore. From Joe?
Yeah, just to summarize what I understand about this is the creator contract as is front runnable. That means that if you see a transaction to the creator contract, you can take it, submit it yourself, and you'll get the same resulting address. Normally, when you have this, you want the caller, right, the message sender to somehow be significant to prevent front running attacks. And so you would want this here. But then we also want, at the same time, the address to be independent of the caller whenever that's fine. So it's a bit of a difficult situation. One potential solution is the creator contract should ignore the caller. But then if we do that, it's like the default way to deploy contracts is insecure in most cases by default. So one could say the default way to deploy contracts should be another factory, some ERC factory deployed from the creator contract. Now, the problem with that is that this needs to be deployed first. It's not going to be built into the chain. And that makes tooling a little bit harder because you need to deal with that edge case. So I don't see a clear solution here. One of the options was to add an optional flag to hash the caller into the salt, but that adds complexity.
It does. Were we going to add a 4-byte selector into the calls into this anyway, so it's friendlier to Solidity? Or were we just going to take it straight flat? Because if we add a selector, then it's easy to make two methods. And just recommend one is the safe and one is the unsafe. Actually put that in the word. And it's unsafe, and you would need to make sure that there is no state that depends on who called the creation. So if you're deploying, because I think there needs to be a method. I mean, if we need one that doesn't have any of the sender addresses in there to get a toehold contract, to get a universal toehold contract. So that needs to be available. And if we don't have that, then we would need to rely on you would have to use Nick's method at least once to get a consistent toehold contract, which has, as mentioned before on these calls, has problems with the gas coding in some of these. So
actually, I'm thinking one thing now. The caller is not visible inside of the init container because, well, actually that depends on whether you do call or delegate call into the creator contract. But if you do a call into the creator contract, then the creator contract is the caller. So then the front running in that case would only result in manipulating TX origin.
And you might use TX origin to set your contract owner too, which is something an audit would flag, but somebody's going to do it and blame us.
No, in that case, I think it's already kind of widely understood that TX origin is bad. So I'm less concerned about that.
But it's hard coding selector into the original creator contract that much better than having like an ERC factory, which is standardized and it's also deployed with standard address. Is that not also problematic? Are these not equally problematic to tooling?
Because we could use the unsafe one to do an immutable. Doesn't matter who sends it. Get the ERC that's the standard safe one. But then people would probably I doubt Solidity would want to build it into their compiler. I don't know. I don't have the experts not in the room.
Like I think it opens up like configuration issues that we actually seeing on testnets right now.
Yes.
That you need to make sure like it shows up on many different devnets and testnets and like other chains.
Right.
So it's kind of lowers the guarantees that the contract will be there. But this one will be there by like fork definition, right? So whatever chain has this fork implemented, you know the address will exist.
But by the way that the addresses are computed, if the behavior of the new factory is the same, then you can expect that the address is going to also be the same.
Do we want to have the auto deploy of it built into every single Solidity produced contract, or do we want to have that be something like a library decision? Ben's got his hand up. You got something to add, Ben?
I mean, you could have one that's only init code, and then if you're front run, it doesn't really matter because, they're deploying the same contract. Oh, I suppose unless it's taking sender in the contract. But
right, it would right. The contract we need TX origin or sender because
not necessarily either. If you're just sending a neutral contract that has no owner, like a utility contract, then if you're front run, who cares? Because it just means somebody else paid the gas.
Right. If there's only one way for that contract to result. But there's cases where you might want to use like TX origin, or if you could get the sender in to set the owner of the contract, because that's something you would want to do in the init code. But there's also no way to do a delegate call from a transaction yet. So you're always going to be you're going to be in context of whoever you're calling. So you will be the sender.
It's an existing problem. If you want to take like a big contract.
Yeah. So who's got the strongest opinion on this? Because this contract needs to be audited. That was established last week. And once we get DevNet up and running, we can start the audit cycle once we're fairly certain we're not going to change it anymore. So if we don't have to be, beyond certain that we're right, there's room for us to be wrong on it, but the auditors will be the ones telling us to fix it. So we should make their job easier, but yeah. Who's got the strongest opinion on this? They get to make the decision. Should we apply the circuits method?
How about we go with the simplest version and with the note somewhere that this is concerning, and I don't know. I mean, I'm not sure who should have the final word on this.
The auditors.
But if we don't have if we don't have like a specific solution right now, maybe we should pick the simplest to like move it on. And already keep this node somewhere that, it shouldn't be like secret and we waiting someone to find it. I think it's better to have it written somewhere that we kind of have some concerns, but I also don't feel expert on contract auditing. So
yeah, Ben.
I'm just following up with the simplest. Probably the simplest that allows us to deploy the next more complicated, if you know what I mean. Does the simplest version enable like a trustless deployment of a more advanced version? If that makes sense.
Just from my understanding, the problem here is if somebody front runs your creation contract, and what exactly is front run? Basically, the address that is going to be created.
So they would see your transaction in the memory pool, and they'd see that your contract sets the contract sender as the owner of it. So they run it themselves, and now they're the owner of your fancy NFT. That is something. Just don't do that. Yeah, don't set sender with But I mean, if you do other things, like if you do things like set the sender in arguments that you pass in can similarly be front run and modified. Everything would need to be immutable.
Either way, you can redeploy your transaction with the different
So we're not.
Yeah,
passing an
you need to create new transaction and sign it all over. So because it was front run and you cannot generate that NFT, whatever it is.
I'm surprised init code hash isn't part of the address.
It is in the first creator contract.
The TX hash is. Oh yeah, in the first creator contract, yeah, the TX creator is, and we're not including the sender hash to guarantee total contracts.
Yes, in the creator contract we have init code hash, salt, and input data. And
I mean,
becomes final salt, and that final salt is combined with sender, but the sender is already the address of the creator contract.
I mean, you do have really odd things where people try and work around the fact that init code is included. Where you have like, I think is it create 3, where it creates a a contract that deploys a contract and then like self-destructs, so that you're doing a create 2 to do a regular create off the nonce to get rid of the fact it uses init code in create 3.
Yeah, I think we're trying to get rid of those hokey steps so we can optimize some of the create 3 operations. So we don't have to, because we can't self-destruct. We can't self-destruct in EOF.
Yeah, I think that's just more cleaning up. But yeah. And people spend like weeks trying to generate the perfect address, not based on GPU mining.
So this is, once we get this nailed down, I want to write a blog post about how we're handling deploys. And I think this is a feature because they can mine the data and it's not tied to a specific account. It's tied to the argument data of the call. Anyone can pay for it on any chain. So that's when I say we get rid of Nick's method, we solve this problem, and they can use market rate gases. And so you get to some of these chains that have default high GUIs, like, well, I don't know if Monad's going to do EOF immediately, but Monad starts at 50 GUI for their default on their testnet. And that's a pretty high number. Hedera was at like 1,000 at one point. So this would solve a lot of those problems.
And I think, is it ZK Sync? They don't allow the anonymous transactions, pre-signed ones. So that breaks. Yes.
Frangio. Frangio, you have your hand raised. And you're on mute. Is he trying to chat? All right, so Frangio, come off mute whenever you want to talk. So I think we'll just go with the simplest for now. That might change. We'll get feedback in the next 2 weeks.
We should get feedback from maybe the tooling side of things.
Yes.
Frangio mentioned that they will not be happy with having to have a default deployment method but use an ERC source address, I guess, which is less certain to be a specific value, single value than the creator contract address, which we use.
Right. The question is, would they want to require people to put it in their Solidity and have that pre-deploy in everyone's contract, or would they want to put code to poke at it inside of their dev tooling or not? That's some of the things we need to ask. And I tried to ping Foundry a few weeks ago, but I just need to ping him again and be more insistent I get an answer. Who else? Foundry, who's still in business?
Con, they call me.
Con?
Yeah.
Oh, yeah. Con.
Like to put you on the spot, maybe.
Is Brownie still a thing?
No.
Okay. Web3.js is not a thing. Yeah, they full on archive their node. They're full on archive their GitHub repo now. All right. Have we said enough about the DevNet 1 changes? Does anyone have any questions? I posted the PR for review. Darn it. This should reflect all the changes if everyone could review it. If there's anything I missed in the things we talked about, bring it up in comments. I tried to fix it at first. If this gets approval from everyone in there, it'll auto commit, but we can always go back and change things we missed later. But most of this is return contract return code changes and some other motivation section changes. $7873. This is an old build anyway. Yeah, and I'll review some of these changes in here. So thanks for putting these in. I'll review them and get them in. It won't auto commit until I fix this lint issue anyway, assuming I get approval. And this might split up into multiple PRs. We'll see. Frangio.
Can you hear me now?
Yes, we can hear you now.
Okay. Yeah, so I'm not feeling very well about the whole front running thing. To me, having like such a core thing be front runnable is a real problem. And it's not only about TX origin. Like anything from the transaction context could change. Like I don't know what could happen if like you include some blob in the transaction, right? Does that affect the contract deployment in any way? Or any future transaction parameter that could be readable within the init container could result in a problem. So to me, the simplest safe path forward would just be to like include a single byte at the start of the creator contract call data that just says, do you include the caller in the hash or not? And that's it. Like it's not selectors. There are no selectors currently. Just a single byte to configure that, and that gives you the option to do cross-chain deterministic deployments, but also a safe default that doesn't have footguns.
What we kind of reverse the chain of action that we always include the sender, and then you can deploy the factory that actually omits that. So it's kind of stripped out version of this.
But the toehold, it would need to have the same sender on all chains.
Yeah.
Including all future chains that don't exist.
So it's a feature but has bug in it, right?
Yeah, and I think we actually call the flag unsafe deployment to discourage people from just casually turning it on. So if you know what you're doing, you're fine. If you don't know what you're doing, we told you it was unsafe. Okay, I'll include that to the notes when I talk to the developers on that. Probably need to think about it for 2 weeks. Let's move on to pay opcode. William, you want to lead us? Do you need the screen?
Yeah, I'm going to try to present my screen.
So let me stop sharing. There we go. You're sharing now. Awesome.
Okay. Cool. So I'm here to present pay as an important part of EOF security. EOF, one of its goals is to abstract gas. Thereby, the gas opcode has been disabled. 4 opcodes with gas parameters are disabled in EOF. So there's this rationale for the G call stipend, and that's how much gas is provided to a call when you supply 0 gas in those opcodes currently, if there's a value. So Solidity, they pass 0 gas in transfer and send. These are kind of basic ways to transfer Ether if you don't want them to gain full control of the execution context. So this stipend is enough for log and T-store, but it's not enough for S-store or G-call value. So the expectation is they can't make changes and they can't call back into you if you supply 0 gas, but they do have enough material to log the change, do some basic minimalist operations. So these gas restricted transfers, they're safe against gas griefing and reentries. So there's a problem in EOF right now, and that's that the only way you can transfer ETH is with EXT call. And so EXT call forwards all of the gas, minus a tiny, less than even call right now is left behind. And there's no other way to do it. And so thereby, anyone that you want to send Ether to, they might be able to grief you, for example, minting gas tokens with your extra gas using the legacy gas opcode. They can keep looping until you have a like 90% of your gas gone for them. And this is, I've seen gas griefing in production. People put it in ERC20 tokens. There's even a scam where they do ERC20 approve and they trick wallets into revoking that approval. And then they mint gas tokens for the scammer. There's a workaround for EOF. So EOF can still have a gas restricted Ether transfer. They just need this proxy contract I have here. It starts with 5F. That proxy contract would then transfer the remaining gas with 0. And so you could use this proxy contract to deliver Ether in a safe way as before. But this is not ideal because there's an extra Ether transfer and you have to go through this proxy. So I'd prefer that not be how it's done. Instead, I want the pay opcode to keep these Ether transfers. So pay is quite like EOF. There's no gas parameter. The Ether transfer is the recipient works for address space extension as the other EOF opcodes. The pay works like call with 0 gas, and so there's no need to preserve 0 gas to maintain feature parity. For the most common use case of call with 0 gas, the only case where I use it and when Solidity uses it is for payments. Everything else you need gas because you're expecting them to execute. And I'm almost done, but hopefully Solidity can implement transfer and send with pay. And there's also this idea of a right to reject that's commonly brought up in objection to the pay opcode. But there's already 3 other ways to pay. And so I don't think this is a great reason to prevent reentry and griefing on payments. So that's all. There's a question from Ben.
Doesn't when you cut the gas in a transfer, so like the current recommended way is not to use transfer, because if you send it to a multi-sig, then which is say a multi-sig, which is a proxy to another address, then there's not enough gas, and generally it will fail.
Well, if it's a proxy, then it does have enough gas to do delegate call. Then that delegate call can emit a log, and I think there's enough gas for both of those operations. But not if the recipient is a cold account access. For example, if the proxy implementation in that case is a cold access account, then 2300 is not enough. So pay would work in that case, but not transfer and send.
Okay.
Daniel?
Alex has a question.
Just some feedback on the stipend. We actually try to get kind of rid of it. And the reason being, it has been an issue making changes to gas for the exact reason you described. The point of the stipend was to try to limit what you can do on an Ether transfer. And the goal of that limitation was to avoid writes and nothing else. So like state changes, excluding logs. And the way this was achieved with the stipend, which caused issues in repricings, because you always had to make sure that nothing breaks there. So my suggestion is, I think if we introduce a pay opcode, it shouldn't follow this old broken metric. It rather should introduce. I mean, in that sense, no, you said.
Gas. Go ahead.
You said it still has the stipend.
No, no, we get rid of that. It just transfers the Ether. It's been the specification of the pay opcode to not give them an execution context at all. That solves this problem entirely.
Okay, it's unclear to me what it exactly means, to be honest.
Oh, it's similar to how self-destruct the parameter just receives the Ether. This pay opcode, the recipient just receives the Ether, which is why I discussed the right of refusal. There's no way to refuse this Ether, just as with self-destruct, priority fees, or beacon withdrawals.
What is the gas limit they have?
The gas what?
What is the gas limit they receive?
They don't receive any execution context.
Then they cannot do logs and cannot do...
Right.
Exactly, that's the point of it.
Yeah, it's more like self-destruct, not like a call with gas 0.
Yes. It's also like priority fees. The Coinbase transfer that happens implicitly in the block also behaves this way, and beacon withdrawal also behaves this way. So it's always been possible to receive Ether without getting a callback.
I mean, there was always a debate between this, and some people really wanted the non-execution approach. Others wanted the execution approach with no writes. And maybe the people with the no execution approach have won because of the withdrawal stuff.
This delightfully gets rid of that call stipends that needs to be tweaked anytime the gas gets tweaked.
What I was going to
done the whole time.
What I was going to suggest that I think, at least in my word, the ideal pay opcode would do execution, but would restrict all the opcodes doing writes. So it could do reads, but no writes, because that makes it work with multisigs and contracts. You don't need to like scan the chain afterward. But yeah, that's my 2 cents.
Well, yes, but this can't simply be the same as static call. And so it'd be yet another kind of permissioned execution, because they want to be able to do log, and you can't log in a static call context. So that does add quite a lot of complexity. And so I'm opposed to it. I do like that it doesn't have any ability to make changes. That does remove a lot of the incentive for griefing, but griefing can still be done maliciously. If you're paying with priority fee, for example, the block builder can get more fees by having you execute more gas. And so they'll use up to your limit in order to extract priority fees from you. Yes, Frangayo.
I don't really think that this is a good way to protect or get security. I think there are better ways to like prevent reentrancy. So I don't really think this is necessary, and I wouldn't include it in, at least in EOF's initial release. That said, one alternative proposal just that we could consider is to add a value parameter to ext static call. It's a little unintuitive, but I guess the value transfer happens before entering the static call, so it doesn't violate that. And it still provides this protection of like no modifications that the gas stipend initially wanted to achieve. But again, I don't really think this is necessary personally.
Oh, so again, with the static call, the most common thing I've seen done with the gas stipend is to log, and you can't log in static call. And so you wouldn't be able to transfer to entire categories of accounts. For example, there's a block builder. I want to say it's STETH. They receive Ether in the Coinbase transaction and they emit a log. And so if you don't supply them with enough gas, they revert and then they don't receive the Coinbase payment. But I'm sure there's others, but that's the only one I'm familiar with. So you wouldn't be able to use that to pay them. And these limitations would prevent me from using EOF because I worry about gas griefing and reentrancy. I understand there's other ways to defend against reentrancy, but not gas griefing.
Well, what about setting a gas limit? Why isn't that not a protection against gas griefing?
You can't set a gas limit for EXT
at the transaction level.
Oh, yes. The transaction level gas limits is also a way to do this. Yes. You would have to model for that. But in the case of the gas token exploit I mentioned, where people trick users into minting gas tokens, they just do ETH estimate gas and then approve that transaction anyway. So they think they're revoking approval to some malicious contract for a token also called USDT, but then turns out they're minting gas tokens for a scammer. So they will just approve whatever gas limits. They don't know that it's unreasonable for 30 million gas to be used to revoke approval.
Is this attack still viable? I thought that some network upgrade had made gas tokens not anymore viable.
Gas tokens still have monetary value, and so scammers still use that mechanism to grief people and make money. Gas tokens aren't as valuable as they used to be, but there's still a way to convert gas into value.
I mean, if you're getting them for free,
yes,
there's a differential.
Yes. Well, thank you for your consideration. I may not be able to present this during the next, so please discuss with your team. I think this is an important part because I wouldn't be able to use EOF without this for my own use cases. Thank you for your time.
All right. Yeah, we'll keep that under consideration. If you're not at ACD, we'll figure out how to best advocate it there. Probably use your presentation.
Yes, I can add any of you as owners if you would like to modify it or add anything.
I think I just present it straight. I wouldn't change it at all. I want to make sure you're represented the way you want it to be. But my concern based on just the discussions today is there's not enough consensus to add it. And I'm not sure that going to all core devs will improve that just to manage expectations. There's a chance that they could change their mind and change people's minds. But if I had to project what would happen here, it probably would not be in DevNet 1 and probably would not be in Osaka. But presented in all core devs and willing to take direction from them to add it if they tell us to. Okay.
I would add, I think it's going in the right direction. That makes sense. I'm not 100% sure on it, but I think it's definitely covering a needed angle that's not present.
And again, we may come to consensus, but just today I'm not seeing the consensus right now. Consensus changes over time. But yeah, definitely bring it up next week, assuming it's also not chock full of what went wrong with the test nets. Another thing we need to manage. So what else is left on the agenda? Metadata section, ext code. Kanan, do you want to talk about, could you do metadata section in 6 minutes? Khan?
Like a recap or?
Well,
I mean, one thing I brought up when discussing with you and maybe also here I don't have much time though, but it will be ideal if we could exclude the metadata section from the init hash part when creating the contract. That way, like any metadata would not affect the contract address, which is currently a problem. That's why a lot of projects like Uniswap are opting out of the CBOR encoding completely, or like the metadata hash completely. But I don't know if that's possible.
Okay, yeah, I'll write that down. Yeah, we'll have time to go over this in 2 weeks. But yeah, I wanted you to state that that's the big concern you have with metadata. I think so. That's something for us to consider and contemplate on. The XC code address and the XC code type, I think, don't have any outstanding questions. And whose hand went up and down? I missed it.
Had small comment about the metadata, but leave it till the end if you want.
I think we're at the end. We're going to get kicked out of here in about 3 minutes. So go ahead and share what you can.
Yeah, so I think the reason why people have not liked metadata in the past was because of the difficulty of getting verification to work on Etherscan for Solidity. But as far as I know, this has been solved for a while now. Unless you're like really not, I don't know, not doing proper version control or like managing your deployments, but the tools to do that properly are all there. I don't think making the address independent of metadata makes sense, and you get similar problems about like front running that we had been discussing, right? So I would like to hear more if I'm wrong about that, but I don't think anyone would really want to omit metadata for any good reason.
Okay.
The problem I was referring to is more so like the verification part is one problem, and metadata section helps with that by having a separate section for that, and you can look at the metadata section and omit that section when verifying. And the other problem is has been the create to problem, where people want to have like deterministic deployments, and when the metadata hash is sensitive, instead of like using that, they completely opt that out. That's why, like,
if you recompile and get any changes to the code, the TX hash is going to change anyway, regardless of the metadata.
Yeah, but the problem was the metadata hash changing, not the code changing. Am I getting it wrong?
So, but if you're doing a truly reproducible build, the metadata hash will be the same, unless you put like date times in it. Exactly. I mean, if it's a fully reproducible build, you'll get the exact same metadata hash.
Exactly. Yeah, but then people were not being able to do that. So I don't know. Maybe we can discuss this later. I don't have strong opinions on this, but this was a small problem that I could see, but it's not a huge problem.
Okay. Well, we're about to get kicked out, so I think we should end it here as open questions, and we'll discuss it. We'll see how far we get next week. Again, the first priority is to make sure we get the creator contract down, and then probably a recap of pay, and then we'll come to metadata. So I think that's where we'll be in 2 weeks. All right, I'd like to thank everyone for coming. Thank everyone for their contributions. Y'all have been a great help. Thanks.